So this is about slope. Unfortunately, we're to a point where I've kind of done everything that we can do in the calculator. But I'm going to hit a couple more key concepts that we still need to know how to do. So the first one we're going to cover is slope. If you remember, slope is rise over run. So we just need to pick 2 points that this graph goes through. I like intercepts if they have them. So it definitely crosses there at 4. I'm going to pick this one at 8. So let's do rise over run. Now, you can't do tick marks. Let's count. I'm going from 4 to 8. So how many am I rising? It's not 2, and that's what I want you to see in this graph. I'm not going up 1, 2. I'm going from 4 to 8. So that really means I'm rising 4. And then running, I'm going from 0 to 2. So I'm running 2. So my slope is going to be rise, which was 4, over run, which was 2. And 4 divided by 2 is 2. So that slope is 2. What if they give you a table? Well, slope of tables is y2 minus y1 over x2 minus x1. You need to write that formula down. And we're just going to make 2 ordered pairs. And I just like to pick the first one. So I'm going to pick this ordered pair, which is 0, 10. I'm going to pick this ordered pair, which is 1, 17. And remember, we label them as x's and y's. Ordered pairs always go x and y. And then these get 1s, and these get 2s. And then it's just a fill in the blank game. So y2 is 17, minus y1 is 10. On bottom, x2 is 1, and x1 is 0. Now I'm going to subtract. 17 minus 10 is 7. 1 minus 0 is 1. And we're going to divide those. 7 divided by 1 is 7. So the slope of that table is 7. What's the slope of the equation? We covered this last week, guys. Remember, slope is with the x. Slope is with the x. So what's the slope of this equation? 2/3. 2/3 is your slope. All right, how to tell if something is a function? We do something called a vertical line test. A vertical line test. And what that means is we're going to draw a straight line, and it can only touch once. It can only touch once. So let me do some that are not first. This circle, if I drew a vertical line, it touches here and here. It touches twice. So this one is not a function. Same thing here. I draw a vertical line. It touches twice. So this is not a function. This one is the tricky one, B, that people usually get confused on. Because if I draw a line here, it only touches once. If I draw a line here, it only touches once. But if I draw a line here, it touches once, twice, 3 times, 4 times, 5 times. It touches an infinite amount of times. So this one, again, is not. Because if I drew that vertical line right here, it would touch a bunch of places. This one, this is a function. Because no matter where you draw a line, it will only touch once. So that's the vertical line test. All right, we got some more ranges. Well, range is y. And range goes down. You already wrote this down. And it's y to up. So let's look at this graph. How far down does it go? Well, this is the lowest point, which is at 1, 2, 3. -3. So it's not A and it's not D. Does it touch at -3? It sure does, which means it should have the line under it. So it's C. Now let me show you how they got the +3. Down to up, this is as high as it goes, which is at +1, 2, 3. And again, it touches, so they put that line under it. So that should be C. Okay, so let's look at this. I want to know, for any real number, where is x to the third greater than 0 true? So I'm just going to plug them in. I'm going to plug in -2. I'm going to do -2 to the third. Now, you have to be careful, because if you're plugging in negatives in your calculator, you got to put it in parentheses. So I'm going to do -2 to the third. And I get -8. And I did it to the third because that's what it says to do. Now, it's saying -8 is going to be greater than 0. Is that true? No, it is not true for this one. Let's try 0. If I do 0 to the third, I get 0. Is 0 bigger than 0? No, it's not. It's equal to 0. It's equal to. So no, because it didn't have that line underneath the inequality. It's a big old no. Let's try positive 3. If I do 3 to the third, 3 to the third, I get 27. Is 27 bigger than 0? Yes. So this was only true for C, right? A was wrong and B was wrong. Because for A I got a negative and for B I got a 0. So C was the only one that worked. Which expression is equivalent to this? All right, this was another one where we are going to put it in our calculator for y equals. And we're going to graph it and see what this graph looks like. Let me put parentheses though. So I'm going to do 4x minus 5. And then minus, and I'm going to do a 3x plus 2. I'm going to graph it. So remember, that's what I want my answer to look like. So let's type in A. A is x minus 3. Let's see if I get that same graph. Nope, that's not right. So let's try B. B was x plus 3. Let's see if I get that same graph. There's the first one. Nope, that's not right. So let's try C. X minus 7. Graph. There's my question. And there we go. We got my answer. So C is the answer here because I got the same graph. Okay, so remember this we did last week too. I'm going to type in my questions, my 4x plus 8. I'm going to do second graph. And I want to see if it goes through these points. 0, negative 8. So let's look right here. Nope, it goes through 0, positive 8. So that's wrong. So let's try 4x minus 8. Does it go through 0, negative 8? Sure does. Does it go through 3, 4? It sure does. So that was easy. B was my answer. All right, let's talk about these problems. So this is the problem of ax squared, and this is 0.2x squared. And it wants to know which graph looks like that. Well, if I get one like this, I'm just going to graph it. I'm going to see, I don't know, let's see what 0.2 x squared looks like. Let's graph it. Ooh, it's wider, okay? So I want to pick the wide graph, and it still goes through 0, so I would pick A. Now, I'm pretty sure on the worksheet what you need to know and remember is that the smaller A gets, so the smaller A is, the wider the graph gets. So because here it was probably a 1, so I'm going from 1 to a 0.2, I'm getting smaller, which means the graph was wider. If I got bigger, the graph would be narrower. So like if it said, what's the graph of 2x squared? That's probably going to be this one because it's skinnier. All right, and let's talk about linear and exponential. Linear graphs are never going to be percents. They're not going to be quadratics. Remember, like x squared, if it ever has a squared, that's a quadratic. That's not linear. So linear is like it's changing per this every day. That's linear, okay? And that's the same amount. So let's read these. Which could be linear? The amount Jeremy tips at a restaurant is a function of the total bill. He tips 15% of the total bill. Okay, well that's possible. Area of a square. Well, I know that's not right because area is side squared. And if it's squared, that means it's a quadratic. So B is wrong. Distance a ball travels after being dropped. Well, look, if I dropped a ball, it'd go like this. That's not linear. That's another quadratic. And again, if you didn't know that, that's what the graph would look like. It says squared. Squareds are quadratics. The length of the side of a rectangle with an area of 48. Well, again, we're at area. And area is a squared. So this one is going to be A. All right, this one, which describes the growth of both populations. Well, let's look. Population A is 800. It's growing by 5% each month. B is 500, and it's growing by 20 each month, okay? If it's growing by the same thing every month, that means it's linear. So 20 each month is linear. If it's growing by 5%, that means it is exponential. It's going to keep exponentially growing. So A would be exponential, and B is linear. All right, which situation must be linear? If it doubles each hour, that means we're not increasing by the same thing. We're going to keep doubling, so it's not A. The amount of money earned daily at a school fundraiser increased the first week and then decreased. Well, that's not linear. Linear's got to be a straight line, so that means it's saying it's going up and then down, and that's not a straight line. Curves. The total cost of stamps, giving that each stamp is 48 cents. So that means each stamp I buy, I'm going to go up the same amount. I'm going to go up 48 cents each stamp. So that's the one that's linear. Let's talk about why this one is not. The amount of radiation decreases by half each hour. So again, it's not saying like we're going to decrease by 2 every hour. It's saying by half, and that is an exponential decay problem. So C is the correct answer. So that's it. If you will go try the EOC 9 worksheet and let me know if you need help.